We can use square brackets to access individual array elements. We can also use them to access subarrays with the slice notation marked by the colon character. So we try to access a slice of an array, say array ARR like this. Then we can use the notation ARR start, stop, step inside our square brackets. Now, if any of these parameters are unspecified, then the values of start will default to 0, stop will default to the size of the dimension, and then step will default to 1. So in this tutorial, we're going to be looking at some of these concepts. We're going to be looking at negative indices array, which essentially flips our array. It flips the element of a array by swapping start with stop. And then we're going to be accessing rows, columns, like single row or single column by combining indexing with slicing. We're also going to be looking at how we can slice a multi-dimensional array. So let's get into it and then implement some of these concepts. So we're going to start with a one dimension array. So for instance, we can do x equals np dot arrange. You know how this works by now. 10. So it's going to give us a okay. So my bad. I should have started with importation of numpy as np. Okay, now we can do x equals np dot arrange 10. So it gives us, so when we say hex, and now we get values from zeros to 9. Okay, so how do we go about this? So we wish to access the first 5 elements in this array. Then we can do, for instance, we can do x, and then we have square brackets, and then we have this, and then we have this. Now, we say that what is it? Yes, this is the parameter we're using, start, stop, step. We said if start is unspecified, if the value of start is unspecified, it defaults to 0. If the value of stop is unspecified, it defaults to the size of the dimension. And if step is unspecified, then it defaults to 1. Now, when you look at what we have here, you realize that we didn't specify for start. So when we didn't specify for start, well, that's 0. We specify for stop, so that works. And then for step, we didn't specify. So we're going to step in one movement, one like that. So here it's saying, okay, get the first 5 elements. So remember, the start we didn't specify, so we start from index 0. So get the first 5 elements. So if I'm correct, then this should give us 0, 1, 2, 3, 4. Okay, so this works. We can also do something like, so for instance, we did x, and then we do 5. Okay, so here we go from 5. 5 is our start. We didn't specify our stop, so that defaults to the size of the dimension. And then our step is 1 in this case, since we didn't specify it. So here it's saying get all the elements from index 5. So all the elements after index 5, sorry. So get all elements after index 5. So if you look at this 0, 1, 2, 3, 4, 5. Okay. So I think 5 is going to be included here because of the way this thing works. Okay, so we have 5. So perhaps I was right in the first statement I made, which was get all elements from index 5. So it's starting from index 5, 0, 1, 2, 3, 4, 5. So all elements there from index 5. Okay. Uh, what if we try to get a middle subarray like X, and then we do 4, 7. So we have start, stop, then we're stepping by 1 there since we didn't specify it. So this is saying, okay, get all elements from index 4 to index 7. Okay, but then the way this slicing thing works is where it stops one step from the final value A. So 0, 1, 2, 3, 4. This is index 4, 5, 6, 7. So it's going to stop at 6, one step prior to the final value A. So if I press enter, okay, so we get 4, 5, 6 like that. Let's do one more. We can also do, or we can do X, and let's do this, and this. So this is stepping by 2, all elements from the first index. So this is, what is it called? Every other element that we step by 2. So remember what is it? Our, the way we specify our syntax for slicing array: start, stop, step. So the first parameter is start, second parameter stop, third parameter step. So here, a terminal, here we didn't specify a start, we didn't specify a stop, only our step. So 0, the dimension of a array, and then we step by 2. So enter. So we realize it's stepping by 2 from the first index, like that. We can also do, let's do X, and then we have 1, this and this. So I should close this. So what is this telling us? It's saying every other element starting at index 1. Every other element starting at index 1. Okay. So if we have this, so we have every other element starting at index 1. Don't forget our last parameter, which is 2. So we are stepping by 2. So that's why it went from starting from index 1 is step by 2. We have 3, step by 2, 5, 7, 9, like that. Okay. Now let's look at negative index value. So when we use negative index value, what happens is our start and stop are swapped, and then our array becomes reversed. So for instance, if we do X, and then we do this, and then we do -1. So this reverses our array. So if I press enter, see, it reverses our array. You know how this, if you've been following our series, you know how this minus value works in this environment. So this is stepping by -1, which ultimately reverses our array. What if we did this X, then we do 5, and then we do -2? So what does this do? Does this reverse every other item from index 5? It reverses every other item from index 5. So we're starting from index 5 here. So we're going to reverse the elements of a array we're also going to step by 2. So from index 5, so this is 0, 1, 2, 3, 4, 5. So we're going to reverse from here, and we go to step by 2. So I think we should be getting something like 9, 7, 5, if I'm not mistaken. Okay. No, I don't think that's what we should be getting, because we're saying from index 5. So we're going to reverse from index 5. So I think that should be 5, 3, and 5, 3, and 2. So we are reversing from index 5. So not like this. It should go like this. Okay, so it should be 5, 3, 2. Oh, 5, 3, 1. Sorry, because we're stepping by 2. Okay, so that works. What else? Let's look at multi-dimensional array slicing. We can do, let's do x2 equals to, remember, we can do random dot, no, we can do np dot random dot rand int, and then we can specify our interval, let's say 0, 10, and then we can specify the size of a dimension. So if I want to have 2-dimensional array, for instance, then I could do 3 by 4. So that's the size. And then I press enter, and then can do x2. Okay, so now we have a 3 by 4 2-dimensional array. Now, how do we slice this? Let's see. So if I do x2, and then I do 3, and then I do 2, like that. Now, what is this telling us? It's saying fetch all rows and every other column. Fetch all rows and every other column. Now, remember, in 2-dimensional array, we have rows and columns. So the same format still works, still applies here. Here we specify for start and stop. We didn't specify for, what is it called? For step. So here, before the comma, refers to our row, and then this other one refers to our column. So it's still start, stop, step for the row, start, stop, step for the column. So here, we are fetching the first 3 columns. So start defaults to 0. This is stop, which is 3. So that's 3 columns. 3 rows. What am I saying? Apologies. 3 rows, and then the step defaults to 1. So here we are fetching all 3 rows, since we have 3 rows anyway. And then here we're stepping by 2. So start, stop, step. So this refers to column. So 3 rows, and then the columns step by 2. So if this is correct, then we should start from here. We should get here and then here. Okay, let's go. So it's correct. So we get here. So we have all the 3 rows, and then what is it called? All the columns, but we step by 2. So step from here and then here. We couldn't step 2 places anymore because this is just 1. So we have 9, 3, 1, 2, 1, 3, like that. Okay. Let's play with more of this. We can also reverse our subarray dimensions. For instance, we could have x2 like this, and then we could have this -1, and then we could have -1. So this ultimately reverses our array. Remember, -1 it reverses our array by swapping our start and stop. So if I press enter, look at where we were. This is going to be reversed. Okay, so we went from this to this. So instead of 9023, like this, it starts from here, 7301. So it reverses our two-dimensional array. Okay. We can also access rows and columns, like single rows and single row and a single column in our multi-dimensional array. Okay, so we could have, for instance, so we wish to access the first column of x2. So we have x2, and then we could have this 0. Okay, so what is it called? So here we didn't specify anything at all. So this takes our default values for start, stop, and step, and here we just specify 0 for the start of the column. So we just trying to get a single column inside our array. So if I press enter, so it gets, this is what we have, 931. So it gets the first column in our array, 931. All right. What if you try to fetch a subarray comprising of a single row? So we can specify, what is it called? We can specify our row. We can do something like, what is it? The reverse of what we did here by doing x2. So we can do 0, and then we can do this. So this gets a single row, this one, a single row. There's a much cleaner syntax we can use here, 0. And then I think this should still work. Okay, so this works, good. What else can we do? I think now another thing that we should take into another thing we should be aware of in a NumPy array slicing, or another thing that we should be aware of with NumPy array slicing is subarrays in NumPy array slicing. There are no copy views. So when we access subarrays in a NumPy array, what we're doing is we're returning views rather than copies of the array data. Now, this is in contrast with what we did in regular Python list. In regular Python list, what is it called? When we slice, our slices will become copies in regular Python list. Slicing our array or slicing our list, we get copies. But here in NumPy arrays, when we slice our array, we get views rather than copies. So which means if we perform some kind of modification on our array data, then that modification, that operation is going to modify the element of our array. This wasn't the case when we perform slicing with Python list. So I think this thing is better demonstrated than me just talking. So let's get our x2. So this is our x2, for instance. Let's get, we can get, much like we've been doing before, we can get sub, let's say sub x2, for instance. And then this is going to be x. What do we do? Let's do this, 2, and then 2. So here we are, what is it called? We're getting the first 2 rows first two column here. Oh, what have I done? What did I do? Too many indices for array. I said x2 sub x2. Oh, I'm sorry. Instead of x2, I did x. Okay, so sub x2 equals x2. Then we have first two rows, first two columns. Okay, so sub x2. Okay, so first two row and then first two column, like that. Now we've gotten this sub array from our two-dimensional array. Now let's try to modify a value here. So we have x2, nope, sub x2, and then we can set the first row, first column. So we say first row, first column to, I don't know, 84. Okay. Now let's do sub x2. You see? It's modify our value here. Initially it was 9. Now we have 84 because NumPy arrays, they return views, not copies. Okay? So this modification is carried to our original array such that if we do x2, you see, it's modify our array. This value has become 84. Okay. Let's not dwell too long on that. But then we can also create copies of arrays in the NumPy arrays. So NumPy gives us this .copy method that we can use to create copies from our NumPy array. So for instance, we can do x2 sub copy, and then we can do sub x2 like that. So we can do something like this: first two row, first two column, and then we can do dot copy. Okay, so this says we want to copy what we have here. So if I do enter, then I can do x2 sub copy. Okay, so this copies what we have. So having created this copy, then we can do x2. We can try to modify sub copy. Then say I try to modify the first row and the first column. So I set this to 45, for instance. Okay, so x2 sub copy. So that becomes 45. Now, because we're doing this operation on a copied subarray, it does not modify sub x2 itself, such that, remember, we've changed this to 45. Okay, initially it was at 84, now it's become 45. But because we're modifying the copied subarray here, it's not going to change what we have here. So let's try to reprint sub x2. So we still retain the value. Even the original array x2, we still retain what we have here. So if we wish to not return views, say we wish to copy our array, we can use .copy method. I think this is quite powerful, which just underscore the notion that NumPy array is efficient for manipulating and storing of numerical data. Okay. Perhaps one thing I should mention is this concept of reshaping of arrays. I think we've talked about, we've implemented this concept, but I don't think we have actually like explicitly talked about it, and I don't think it would be nice to create a separate tutorial for that. So maybe I should just chip that in here. For instance, I could do grid and then you can do np, what is this, np dot arrange, and then here let's start from 1, and then where should we end? Let's end 10. And then I think the other time I was saying when we reshape, the size of our reshape shoe is going to has to agree with what we have here. So we're going from 1 to 10. So we're going to get 9 values here. So if you've been following through our tutorial, you know how this works now. So we're going to get 9 values here. So which means when we reshape here, we have 3, 3. 3 times 3, 9. So then when we do grid, okay, so we get a 3 by 3 2-dimensional array like that. Okay, so that's how reshape works. We can also do something like this. For instance, we can do row vector. We can create a row vector via reshape, for instance, but I think that would just be tautology anyway. For instance, we can do, how do I do it? We can do A equals np dot array, and then here we can just pass our array here. So it's like creating an array from Python list now. So we're revisiting that concept. So if you do this, okay, and then we can do a dot reshape, okay, and then here we can pass a tuple 1, 3 like that. So we do this, so we get what is it called? We get a row vector via reshape. So this is another implementation, implementation of reshape. Remember, we're passing tuple here, so we get this original array, and then we try to create a row vector. So we do reshape, and then we pass this what is it called, tuple here. So this is 1, 3. That is 1 row, 3 columns. 1 row, 1, 2, 3, 3 columns. So we can also create what is it called? We can create row vector via new axis. So by using np.new axis. So for instance, we can do A, and then here we can do np.new axis. Okay, and then we just specify this like that. I think this should give us a row vector. Enter. Okay, so much like we did there, we get row vector. And then we can also do column vector, for instance. So we can do a dot reshape, and then we pass our tuple here. For instance, we can do 3, 1. So we get our column vector like that. So guys, that's all I have for you for this tutorial. I'll see you guys in the next video. Thanks for watching.